everybody. Here we are. Mr. Mice is here with you again on 1.5a, which is the basic differentiation rules. Now these are just basic rules that we use to make derivatives easier. The last video, one of the last videos in the last section we did were limits, and we did limit definition of derivative. Well, there is an easier way. We don't always have to do the derivative with a limit. So here are some basic rules that we have. We have what's the basic rule called the power rule. Power rule basically says if you want to take the derivative of anything that has an exponent and a variable, a number exponent, all we would do is put that in the front and subtract our power by 1. We have the constant rule. The derivative of any constant is 0. A scalar multiple, so if we are taking any type of function, especially a power rule type function, multiplying it by a number, a constant c, the derivative of that is just the constant multiplied by the derivative of that function inside. And then the sum rule is basically it works for both plus and minus. But the sum of two functions, the derivative of that is the sum of the two derivatives of those functions individually. Alright, so let's take a look at some examples on where that comes to play. Alright, so I have f of x equals x to the fourth. Alright, so we're going to use the power rule, because this is a basic power. We're going to bring the 4 in the front and subtract. So we've got f prime of x. We're going to bring the 4 in the front and subtract 4 by 1 from 1 from 4, and we're going to get 3. And this is our derivative. Okay? Here we're also going to use the power rule, except our power this time is negative 2/3. One thing we want to make sure we do is when we do the power rule, we want to make sure that the x is not in a denominator. Ooh, I can't even talk. We want to make sure that the power is, all in one kind of polynomial-ish. It's not a polynomial, polynomial-ish. Not really a math term, so don't quote me on that one. We're going to bring the negative 2/3 to the front, and then we're going to subtract 1. Now when we subtract 1, we're subtracting 3/3. Okay, we got a common denominator, so we're going to have negative 5/3 power. And then the derivative, since we have a plus here, we're going to do the derivative of this part, and then we're going to do the derivative of 3. The derivative of 3 is the constant rule, which is 0. So this is our answer right here. Okay? Now, remember I said I don't want a power in the denominator, so I'm going to convert this first. I'm going to change this to h of t is equal to 5 minus, the 2 needs to stay down there. So I'm going to say 1/2 t to the negative 3 power. So if we have a t in the denominator, I've got to bring it up to the negative 3rd power. Now we can do our derivative. So h prime of t is going to be, what's the derivative of 5? 0. Now we're going to do the derivative of this part. So we're going to bring the negative 3 in front. So we've got a negative times a negative, which is a positive. So that's going to give me 3/2. And then we're going to subtract the negative 3 by 1 from 1. So we're going to subtract, we're going to get negative 4. Okay? This is our answer. Alright? Okay, last one here. Again, we've got to do the same thing we did for the previous one. So we're going to have f of x is equal to, I'm going to go ahead and do the 2 to the 3rd power and give me 8. So that's 5/8. And I'm going to bring that up x to the negative 3rd, okay? Because this is x cubed in the denominator. So I'm going to have f prime of x is equal to, again, multiply the 3 to the front using the power rule, negative 15 over 8, x to the negative 4, because I have to subtract 1 from that, right? And that's my derivative, and that's some examples of how to use the basic derivative rules. See ya.